Hello and welcome back. Today I have to create something for paintball. A little while ago I showed you guys a spacer I made to go inside the T15 shroud. And a lot of people said, hey, can you sell me that? And I thought, no, I don't want to take anybody's money. As a matter of fact, I'm going to show you guys how I did it because I actually have to make another one and the process that was involved. And you're thinking, great, now I've got to go out and buy all this stuff. Well, to get started 3D printing, it literally costs $250, which could be around the same price as a box of FSRs on a rough day. But enough talking, I'm going to show you guys how to make a spacer for your barrel. Again, YouTube moderators, this is a paintball barrel, not a firearms part. We are not modifying anything per se. This is a paintball handguard. It came from a paintball marker. We're not creating parts for firearms. I don't recommend putting 3D printed parts inside of firearms. It's just a really bad idea. Anyways, let's go over to the overhead view and the CAD view. This is called a caliper. If you guys don't have one, you should think about picking one up. There's a variety of crap in your life that you're going to need to measure or you would like to know the size of. These guys can get down to within the thousandths of an inch range. I know they look like a hokey piece of equipment, but they are more or less reliable and dependable. This one I would call a low-end one. It is made by Mastercraft. It is a knockoff of a different kind of caliper out there. If you want to spend the money and you're really, really into this, and I don't recommend it unless you're like a machinist or you actually own a shop, Mitsutoyo or any of those Japanese measuring equipments, really good. But for the purposes of making stuff for paintball, this is good enough. So I turn my caliper on, I zero it, and again, my CAD program runs in millimeters, so I'm going to be making my measurements in millimeters. And I'm going to do my best to do this in a way that you guys can see the display. Okay. And what I'm going to do is I'm going to turn my barrel all the way around, and you can probably see those numbers going up and down. What you want to do is grab the high measurement. And that measurement is 25.33 millimeters. So I'm going to round this up to 25.5 millimeters. And there's a reason for this that I will explain later on. Whole numbers. Always have to have whole numbers. So now I'm going to flip over to my AutoCAD. I'm going to create a new file, a new sketch. You're welcome to use whatever program you want, and it really honestly doesn't matter. I'm going to create a circle. I'm going to give that circle a diameter, and then in millimeters, 25.5. So I've got the barrel measurement. Now I need to measure the handguard. And what I'm going to do is I'm going to apply a little bit of outwards pressure so that the jaws of the caliper remain constantly pressed against the inside diameter of the handguard. And I saw a 34.7, 34.8. Okay, so we're bouncing around between 34.5 and 34.8. So I'm going to make it again 34.75. I'm tripping on my words today, guys. I'm sorry. 34.75. 34.75. Now, switching over to the AutoCAD view. This circle represents the inside of the handguard. And this circle right here represents the barrel, the outside diameter. Now, when I print this, see right now it's just a drawing. What I have to actually do in this program is to extrude it. Let's extrude this. How long do I want my spacer to be? Let's go with 25 millimeters. That looks like a fairly big gap. 25 millimeters sounds good. So now I essentially have a cylinder. It's not just any old cylinder. It's a cylinder that is perfectly matched to my barrel and my actual handguard because I used a $20 caliper. All right, now let's give this a name. What barrel is this? This is the barrel I got from Nightmare, which is a shark tooth barrel. I don't know what this adapter is, but he gave it to me, and this is the Freak. Let's call it. Oh, there's also the lock bolt on here as well. Okay, let's call it the T15 Shark Tooth. T15 Shark Tooth. And then what I'm going to do from there is I'm going to export that to the desktop. Export unnamed shark tooth T15 shark tooth spacer. Oh, and you guys got to look at some of the behind the scenes stuff you probably shouldn't see, but whatever. Okay. And because this is just a one-off, I'm just going to close that. Okay, now over here, there's a file. Now this program that's about to start up is called Cura. It says right there in the box, the world's most popular 3D printing software at the heart of your workflow. It is true. A lot of the people I talk to that do 3D printing are big Cura fans. So I just run that. I have 3 different printers and they all use the same. Okay, as you can see, this is a display that Cura gives you. This tile right here, or multiple tiles, represents the bed of the printer. I don't need to use my 400 by 400 Anycubic Cobra Max to run this. Seems a bit much. So I'm going to use my Anycubic Cobra. It's a bit smaller. As a matter of fact, the larger printer is printing the bottom of the box mag right now. I could run this in PLA, which is just your standard plastic. Most of the 3D printed objects nowadays are made out of PLA. But I have the capability of running something called TPU, which is a rubber. It's very strong rubber, as a matter of fact. The reason I'm doing this is because it will flex a little bit. The idea of the handguard changed. In some spots, it was 3.75. In other spots, it was 30. Sorry, I got that all wrong. In some spots, the measurement was 34.8, and in other spots, it was 34.4. And if I'm printing out of rubber, what that's going to do is it's going to even itself out when I insert it. And the extra material is just going to be forced inwards towards the barrel and make it grab it that much tighter. No fasteners, no duct tape. I mean, if I really wanted to, I could just use electrical tape, but that would look like ass and it's not repeatable. So, sorry for the rabbit hole. Back to the slicer. Just checking my settings here really quick for TPU. Infill density 25. It actually doesn't have to be that high because we're just creating a spacer. It's really like a throwaway part when you think about it. 50 millimeters per second, combing mode with an infill. Fan speed, print cooling, generate support. I'm definitely running a program. Okay, and then when we're done, we hit slice. What that's going to do is it's going to tell me that I need 50 minutes to print this file. Going to come over for a quick preview. Look at it here. All right, yeah, looks good. No problems. All right, let's get this sent off to the printer. The Anycubic Cobra Max, which has self-leveling and is a direct extruder, has the PEI bed sheet. Some modifications I added myself to this printer that help tram the bed out. Anyways, I'm going to stick the SD card in there. Okay, now I have literally just trammed and leveled this bed, so it is ready to go. Oh, cool little sound there. So what I'm going to do is go over to print.
Find the file T15 shark tooth spacer. Go over to print. Various different print settings. Now I haven't blurred this out on you guys. It's just changing the settings there. It's just a product of my camera. And what this is going to do is it's going to heat up and then start printing when everything's ready. And I will see you guys when it's done.
Well, okay. Okay, as you guys can tell, I clearly stay busy. I have a lot of concurrent activity happening between photo shoots. But here's the spacer. It slides over top of the barrel, like such. And then you just feed it back inside the handguard. And if this was actually attached to the marker, it would be rock solid. Not bad for free, if I don't say so myself. Let the ideas fly. Here's a little teaser for you guys. Hope you enjoy.